Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore, at DG Khan campus. Dear students, our today's lecture topic is Spanning Tree Protocol. So these are some contents regarding today's lecture. Introduction to Spanning Tree Protocol, how Spanning Tree Protocol works, reasons for forwarding or blocking prior to Spanning Tree applications. So these are some contents which will be covered in today's lecture. Spanning Tree Protocol. So dear students, what is STP or what is Spanning Tree Protocol? There are 2 points over here. Point number 1, without Spanning Tree Protocol, frames would loop for an indefinite period of time in networks with physically redundant links. So point number 1 is about the loop condition in any network. You have studied about loop in programming subjects. So there are different loops, for example, for loop, while loop and do while loop. But this is a different concept over here in networks. In networks, if the source or destination address is unknown, then there will be a loop condition. It means if the destination device is unknown, the data sent by sender or the data sent from sender side will be in loop condition. So ultimately, this is not good sign in network. The addressing mechanism is compulsory to receive data by proper intended destination. So second point, to prevent looping frames, Spanning Tree Protocol blocks some ports from forwarding frames so that only one active path exists between any pair of length segments collision domain. So another concept for STP is to block some ports, because if more than one ports are being on and the data is transmitted on these different ports, then the blocking condition will be implemented to prevent this concept, to prevent looping. So Spanning Tree Protocol is basically used to control looping frames in local area network. What Spanning Tree does? The Spanning Tree algorithm places each bridge/switch port in either a forwarding state or a blocking state. We have discussed in detail regarding bridge and switch operations in our previous lectures. So every switch as well as every bridge contains different ports. So these ports are incoming ports and outgoing ports. So likewise over here, Spanning Tree Protocol is used to block some state and to forward some state. Because when there is a loop, to control the looping condition, STP is used to implement this concept. All the ports in forwarding state are considered to be in the current spanning tree. So in current spanning tree scenario, all those ports will be in forwarding state, will be able to forward data, and all those ports which are in blocking state can't be able to forward data. Next point, the collective set of forwarding ports create a single path over which frames are sent between Ethernet segments. And the last point, switches can forward frames out ports and receives frames in ports that are in forwarding state. Switches do not forward frames out ports and receives frame in ports that are in blocking state. So just I have discussed that every switch has some ports and some of the ports are being designated as incoming ports and some of the ports are being designated as outgoing ports. So all those ports, either incoming or outgoing ports, will be able to forward data which are in forwarding state, and all those ports, either incoming ports or outgoing ports, will not be able to forward data which are in blocking state. In this diagram, a simple STP tree with one port on SW3, which is switch 3, in blocking state. So network with redundant links and STP. Redundant links means if there is a path between two devices and that path is being broken, then there must be another path by which data transmission is being done. So this is redundant concept, or you can say alternative path. So in networks, alternative or redundant links are very important, because if the network is failed or the path is broken, then another or alternative path must be able to transfer data. So over here there are three devices named Archie, Bob and Larry, and there are different switches among these three devices or these three users. So you can see switch number 1 and switch number 2 between Archie and Larry, and switch number 1 and switch number 3 between Larry and Bob, and switch number 3 and switch number 2 between Archie and Bob. So this link is in blocking state. So it is not possible to transfer data on this link. So switch number 2 and switch number 3 is not being able to transfer data because this link is in blocking state, and the other links, switch number 1, switch number 2, links between switch number 1 and switch number 3, this is in non-blocking state. So on these two links data is being transferred. So STP is used for this purpose, to block state, to block different ports, and hence a specific path will be blocked. How spanning tree works? The spanning tree protocol algorithm creates a spanning tree of interfaces that forward frames. This is like a tree concept. If a specific tree has two branches and there are multiple different branches of these two branches, so if one side is being stopped or one side is being blocked and the other side is being allowed, so the side which is being allowed is a spanning tree. So likewise, switches has different interfaces. So if one interface is being blocked and the other interface is being allowed, so that interface will be in spanning tree mode. Second point, the tree structure creates a single path to and from each Ethernet segment, just like you can trace a single path in a living growing tree from the base of the tree to each leaf. So this is simple tree concept. In a tree we see different leaves or different branches. So if there is a single path from start to end, from root to top, so that will be a spanning tree in our networking concept. STP actually places interfaces in forwarding state or blocking state. If an interface has no specific reason to be in forwarding state, STP places the interface in blocking state. So if a specific interface is not being used to receive or to forward data, that interface is always in a blocking state. And the last point, in other words, STP simply picks which interfaces should forward and which should not. So in one sentence we can say that which interfaces are compulsory or important to receive and forward data, those interfaces will be in forwarding state, and all those interfaces which are not being used to forward or receive data, those interfaces will be in blocking state. and spanning tree protocol is used for this purpose. How spanning tree works? STP uses three criteria to choose whether to put an interface in forwarding state. Criteria number 1. STP elects a root bridge. STP puts all interfaces on the root bridge in the forwarding state. Let's suppose in any network we have 5 bridges, and among these 5 bridges, one bridge is root bridge. Criteria number 2. Each non-root bridge considered one of its port to have the least administrative cost because between itself and the root bridge, STP places this least root cost interface called that bridge's root port in forwarding state. So if one bridge is root bridge, then the other 4 bridges will be definitely non-root bridge. And all these non-root bridges have different cost from their link to the root bridge link. So that bridge will be chosen which has low administrative cost. Criteria number 3. Many bridges can attach to the same Ethernet segment. Let's suppose in our scenario we have 5 bridges. The bridge with the lowest administrative cost from itself to the root bridge as compared with the other bridges attached to the same segment is placed in forwarding state. So we have discussed that one bridge is root bridge and the 4 other bridges are non-root bridges. And from the non-root bridges, again one bridge is selected which cost is lowest among the 4 non-root bridges, and the all ports are in forwarding state of that one non-root bridge which is being selected. The lowest cost bridge on each segment is called the designated bridge, and that bridge's interfaces or interface attached to that segment is called the designated port. So in short, we have 5 bridges. One bridge is root bridge and the other 4 bridges are non-root bridges. And from non-root bridges, one bridge is being selected and that is called a designated bridge, and the ports are called designated ports because all the ports are in forwarding state. Last point, all other interfaces are placed in blocking state. So all interfaces means the interfaces of all those bridges which are not being selected as designated bridge. Reasons for forwarding or blocking. This table summarizes the reasons why STP places a port in forwarding or blocking state. So on the left side you can see characterization or port, then STP state, then description. So first of all we will see characterization of port. All the root bridges port, these are in forwarding state. Why? Because the root bridge is always the designated bridge on all connected segments. So because root bridge is main bridge, all the ports will be in forwarding state. Second, each non-root bridge's root port or forwarding state, the root bridge is the port receiving the lowest cost BPDU from the root. So protocol data unit, this is again be in the forwarding state. Next, each LAN's designated port must be in forwarding state. The bridge forwarding the lowest cost BPDU onto the segment is the designated bridge of that segment, and the last one is all other ports in blocking state. The port is not used for forwarding frame nor or any frame receive on these interfaces considered for forwarding. So in short, our main bridge is root bridge. All the ports will be in forwarding state, and among all non-root bridges, one bridge will be selected as designated bridge, and all ports will be in forwarding state, and remaining bridges are not being selected, and all the ports of remaining bridges must be in blocking state. So dear students, from slide number 10 to onward, there is implementation of STP. But first of all, we will create a small network and then we will see how STP is implemented. So over here you can see LAN 1 and LAN 2, and these two LANs are connected by a bridge. In LAN 1, two computers are shown and the physical addresses are shown as well. In LAN 2, two computers are shown and the physical addresses are shown as well. And these two local area networks are being joined or connected with the help of a bridge, and bridge has two interfaces, and these are used to receive or forward data. So port number 1 is used for receiving and the port number 2 is used for forwarding data. A learning bridge. In this slide you can see a diagram. In this diagram, bridge is used learning function. So we have discussed learning function of a bridge, in which bridge will learn the MAC addresses of different devices. So over here you can see LAN 1, LAN 2 and LAN 3, and different devices are connected over here, and a bridge is being used to connect these three local area networks. There are four tables, table A, B, C, D. In table A, there is no entry in original table because data is not being transmitted. In table B, you can see after A sends a frame to D, address of A will be learned by bridge. In table C, when E will send to frame to A, address of E will be learned, and in table D, when B will send a frame to C, the address of B will be learned. So in this form, address of A, E and B will be learned by bridge, and bridge will put these MAC addresses or physical addresses in its MAC table. Loop problem. Dear students, in this diagram we will study about loop problem, and this loop problem is being eliminated by STP. In scenario 1, you can see station A sends a frame to station D. So over here there are two LANs, and you can see four devices, two devices in LAN 1, two devices in LAN 2. So device A and B in LAN 1, device C and D in LAN 2, and there are two bridges, bridge 1 and bridge 2, which are being used to connect these two LANs. In scenario 2, both bridges forward the frame and improve stable. So you can see over here, bridge 1 has updated its table by A's physical address, port number 1, as well as bridge 2 has updated its table by keeping the A's physical address and port 1. But you can see over here two copies of the frame on LAN 2 as well as two copies of the frame on LAN 1. So on both LANs, two copies of the data or frames is being transmitted. So this is a loop condition which will be controlled. So in last scenario, which is C scenario, both bridges forward the frame and improve stable. So over here you can see bridge 1 updated table by A's physical address and port number 2, and the same data is being transmitted by bridge 2, again using the A's physical address and port 2. So this is loop problem. So one path must be disabled to avoid this looping condition. Prior to spanning tree application, so over here you can see LAN 1, LAN 2, LAN 3 and LAN 4, and there are different bridges, bridge 1, bridge 2, bridge 3, bridge 4, bridge 5. So this is a simple scenario of local area network in which there are different LANs and there are different bridges. So in next slide we will see how STP is implemented. Applying spanning tree. So over here you can see again LAN 1, LAN 2, LAN 3, LAN 4 and LAN 5. So there are four LANs, and you can see a root bridge which is bridge number 1. So this is root bridge and this is being selected by STP, and all other bridges are non-root bridges. So first main application of spanning tree protocol is to select root bridge. So over here you can see root bridge is being selected by STP. Forwarding ports and blocking ports. We have again same scenario. We have four LANs: local area network 1, local area network 2, local area network 3 and local area network 4, and we have five different bridges: bridge 1, bridge 2, bridge 3, bridge 4 and bridge 5. In previous slide we have learned that bridge 1 is a root bridge and all other bridges are non-root bridges, and you can see the path between bridge 3 and LAN 3 as well as bridge 3 and LAN 4. This is shown in dash line, and port number 2 and port number 3, which is forwarding port of bridge 3. So forwarding ports of bridge 3 are being blocked by STP, and hence we can control the looping issue in a specific networking scenario. So dear students, we have completed our lecture of STP, and over here there is a reference material: Cisco ICND 2004 by Cisco Press, a second book TCP/IP Protocol Suite, second edition by Behroze Ferozen, a Computer Networks, fourth edition by Tenenbaum, and Computer Networking, a top-down approach featuring an internet. This is by Jim Cross. So these are different books. You can enhance your learning to study the topic from these books. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.